Hello everyone, I'm Rajasri, Assistant Professor of Department of EEE, working at MLR Institute of Technology, Hyderabad. I'm here to teach power electronics. In this session, I'll be discussing about Introduction to Power Electronics, why power electronics, block diagram of power electronic system, types of power electronic circuits, types of semiconductor devices. Firstly, let us see what is the difference between electronics and power electronics. Electronics deals with semiconductor devices such as diodes, BJTs to control the electronic circuits. If you see power electronics, it deals with power semiconductor devices such as power diodes, power BJTs and power MOSFETs to control the electronic circuits. Here I have made use of the word power. That means it handles high power handling capabilities. So here electronic circuits, it deals with very less voltages of about plus or minus 3.3 volts, plus or minus 5 volts and maximum up to plus or minus 15 volts. Whereas power electronics, it deals with megawatt of power rating. And here the cross-sectional area of these devices will also be large. And coming to the current ratings of these electronic devices will be about few amperes. Whereas current ratings of power electronic devices will be about kiloamperes. If you see, the main aim of electronics engineer will be providing distortion-free output. Whenever a signal is fed as an input to the load, they'll see such that the output signal is distortion-free. So that will be the main aim of these particular electronic engineers. Whereas electrical engineers are concerned with high efficiency. That means the power transmission capability should be more. The power handling capability of these systems should be high. That will be the main aim of electrical engineers. Power electronics, where it is actually applicable or used. In mobile phone chargers. In mobile phone chargers, see, the conventional power supply is single phase AC to 30 volts. Whereas a battery needs, it can store only DC, and the voltage capability of these batteries will be about 3.3 volts. That's it. That means these require very low power ratings. That means the rating of these particular batteries is very less in watts. Whereas inverters in industrial drives, it deals with megawatt power ratings. That means power electronics, it deals with few watts to megawatt of power handling capabilities. What are the power electronic circuits? Circuits that employ power semiconductor devices are called power electronic circuits. Why power electronics? Power electronics is a technology for efficient conversion, control and management of electrical power and to control the flow of electrical energy. Why power electronics? What is the necessity? Why we need to actually learn this subject? In the olden days, we used to make use of these bulky fan regulators of this much size. This was the size of the fan regulators. Whereas nowadays, in the recent past, the size of the fan regulators was this much. And nowadays, this is the size of the fan regulators. So, with the advent of power electronics, the size of the fan regulators has come down. And here, we are making use of a power electronic switch called triac. That means, with the advent of power electronics, nowadays, the size has come down. That means it is compact, weight is also less, and at the same time less moving parts, that means it is more reliable. That means life will also be more, longevity will be there. Due to the less moving parts, the efficiency is also high. That means because the losses are less, it is highly efficient. So these are the various advantages of power electronic devices. And that is the reason many of the people shows interest in learning in this subject. Block diagram of power electronic system. It consists of a source as well as load, and this source, it can be either AC or DC depending upon the load requirement. Say, for example, I need to run a DC motor over here. That is my load. And here I am considering a converter circuit which converts AC to DC required by the load. And say the rated RPM of this particular DC motor should be 1500 RPM. This is the intended RPM at which this particular motor need to run. And due to some external condition, if say it is running at 1600 RPM, that means there is a difference of speed 100 RPM. So this sensor will sense the speed that it has exceeded, and then it gives away the signal to the control circuit, and this control circuit, it compares the speed with the reference value, that is rated RPM 1500 RPM. Based on this control signal, the converter circuit switches will be switched accordingly. That means by making use of control circuit, we will be generating the firing angles. That means here, since the speed is increased, voltage, either by making use of voltage or frequency, we can control the speed of the motor. Here, by increasing the firing angle, I can reduce the net output voltage. Since voltage is directly proportional to speed, when voltage is coming down, speed will be getting reduced. And thereby, we can actually control the speed of the motor. And how, if firing angle is increased, how the speed is coming down? That is, say this is the input voltage, and now I am triggering this particular switch at firing angle alpha is equal to say 30 degrees. In that case, this is your output voltage which has come down when compared to this. Thereby, we can actually control the speed of the motor by reducing the output voltage. This is how the control circuit will be generating the signals based on the reference speed, and thereby we can actually control the speed of the load. Types of power electronic circuits. We have AC to DC converters, DC to DC converters, AC to AC converters, and DC to AC converters. Firstly, we'll see AC to DC converters. We can also call it as rectifiers. And rectifiers, it converts AC to DC. And coming to the applications part, these rectifiers will be used in DC drives, traction. In traction, the input voltage will be about 25 kilovolts AC. And the motor used in this traction will be usually DC series motors. And for that particular series motor, the supply should be DC. That means we need a converter which converts this 25 kilovolts AC to DC, and then this particular DC will be fed as an input to the DC series motors. And then battery charges. We all know by this time battery charges can store only DC. And then excitation system of synchronous machines. If you see, in order to run these synchronous machines, there are various starting methods. Here, one of the starting method is by making use of a DC pony motor. Yes. So conventional supply is AC. In order to convert AC to DC, and this DC will be fed as an input to the DC pony motor, and thereby we actually excite the synchronous motor. These are the various applications. And then we'll see DC to DC converters. We can also call it as choppers. Choppers convert fixed DC to variable DC. That is, say I have 10 volts DC. I need to convert this 10 volts DC to variable DC of about 5 volts. For that purpose, I make use of a chopper where we can control the turn on time, that is switch is remain on for the period of T by 2 and switch is remain off for the another half cycle. In that case, when a smoothing filter is applied, in that case the average voltage of 5 volts will be fed as the input to the load. And then what are the applications, various applications of choppers? Choppers are used in DC drives, subway cars and battery driven vehicles. AC to AC converters. Here AC to AC converters are also called as AC to AC choppers, and these are of two types. One is AC voltage controllers and other is cycloconverters. AC voltage controllers, we can also call it as AC voltage regulators. It converts fixed AC to variable AC. Say I have 10 volts of source and I need to feed only 5 volts of voltage to the load. In that case, I'll make use of a AC voltage regulator. Thereby, the switch on the turning time of this particular AC voltage controller can be controlled. That is, I'll make it on only for certain period of time and again off for another period of time and again it is on. And if you calculate the RMS value of this particular thing, it will be about 5 volts, which is the requirement of my load. Likewise, we can either step up the voltage or step down the voltage. That is, we can reduce the voltage or increase the voltage by making use of a AC voltage regulator. Coming to the applications part, it is used in speed control of fans as well as pumps. Coming to the cycloconverters, cycloconverters also convert fixed AC to variable AC at a required frequency. We can control the frequency of cycloconverter, whereas we cannot control the required frequency in AC voltage controller. That is the only difference. And cycloconverter, it converts fixed AC to variable AC at a required frequency. And you may ask me a question, why not a transformer then? Yes, transformer also serves the same purpose. It either steps up the voltage or steps down the voltage. But the thing with the transformer is it is bulky, costly and also requires maintenance, frequent maintenance. But the difference why we are not actually replacing whole transformers with power electronic switches like AC to AC converters is because transformers will be handling with high power ratings. That is the reason the transformers are not yet replaced with the power electronic circuits. Whereas power electronic circuits are designed only for certain rating applications, not up till this high rating power applications. That is the only difference. Next is DC to AC converters, or we can also call it as inverters. Inverter is a switch which converts fixed DC to variable AC at a required frequency. Coming to the applications part, it will be used in induction heating, high voltage DC applications, uninterrupted power supplies, renewable energy systems like solar as well as wind. If you observe solar panels output will be DC, and in order to utilize that particular energy, we need to convert DC to AC, where we need a power electronic device so-called inverter, which converts DC to AC at a required frequency. And the other thing is, even in wind systems, the wind turbine speed, it is a constantly varying thing, which is not constant. So we need to convert that particular output to DC, and then we need a inverter set between output to DC, and we need a inverter set which converts DC to AC and AC at a required frequency, so called 50 Hz, and then utilize that particular AC of 50 Hz because Indian standard frequency is 50. What are the types of semiconductor devices? Types of semiconductor devices are uncontrolled devices, semi-controlled devices, as well as fully controlled devices. And here, uncontrolled devices, which includes power diodes. Diodes consists of anode as well as cathode, and there is no other terminal in order to control the turn-on time or turn-off time. That is the reason these diodes are termed as uncontrolled devices. Coming to the semi-controlled devices, examples are SCR, silicon controlled rectifier, which consists of anode, cathode, as well as gate terminal. So, while turning on the thyristor, a triggering pulse is provided between this gate and cathode terminal such that the turn-on time of the SCR can be controlled, whereas turn-off time of SCR cannot be controlled. That is the reason this is termed as semi-controlled devices. Next is fully controlled devices. Under fully controlled devices, we have power BJT, power MOSFET, and power IGBT. If you see the BJT, it looks like this. This is the base terminal, collector terminal, and emitter terminal. So the turn-on time of the BJT can be controlled by using this base terminal. Similarly, turn-off time of this particular transistor can also be controlled by making use of base terminal. So that is the only reason BJT is termed as fully controlled device. Likewise, MOSFET and IGBT turn-on time as well as turn-off time can be controlled with the gate terminal. So that is the reason we call it as fully controlled devices. Under fully controlled devices, we have thyristors also like GTO, IGCT, as well as MCT. GTO is gate turn-off thyristor, MCT is MOS controlled thyristor. So we have seen introduction to power electronics in this session, and in the coming session, we will be seeing silicon controlled rectifier, what are the different modes of operation, and various turn-on methods of SCR. Thank you.